This is the final project for Data Structure and Algorithms 2 by Esteban Zapata and Adelaida Maldonado. First, I'm going to describe the problem and then we're going to show the solution and the code. So the problem. The problem is to develop a program that starts from the academic scheduling and modifies the assignment of classroom in a way that minimizes the average distance a person must travel when finish a class and moving on to the next one. There are some conditions. First, that no teacher has two different classes scheduled simultaneously, and no classroom is allowed to have two classes scheduled simultaneously. And also, all the groups have to have a teacher and a classroom. We have two restrictions that we must solve. First, the most important, that is the hard one, that it must be ensured that all persons with mobility limitations have their classes scheduled in an easily accessible classroom. And the soft one is the average time it takes for a person to move from one class to another. Okay, so the output that our code does is a CSV file with all the courses changed. So the files that was given to us. First is the list of all the students in the university with the courses they have enrolled in. Also the list of groups scheduled for the semester, the list of all the classrooms, and the map of the university in a graph format, and the distances. And the last one is all the students, also saying if they have mobility impairments. So here are our classes that we made, that there is a main, a solution, a classroom, a course, a student, a subject, and a key. I'm going to explain that in the code. Okay, so first I'm going to say for what is each class. The main is where we execute the program. The reader is where all the CSV files are read and store them in hash maps or array lists. The solution is where are all the methods for the analysis, that cleaning the output and making some cleaning. Also, classroom that stores all the information of each classroom. The course is all the information of each subject group. The student, the information of each student. The subject for each subject, and the key is that creates the key for the main hash map for the solution. I'm going to explain the most important methods. So I'm going to go to solution and say, for example, the hard one. The hard method first checks the main hash map of that have all the courses, and in each course see if there is a student that present mobility problems. If a student presents mobility discapacity, then checks if the classroom where the course is accessible for everyone. If the room is not accessible, it searches in a hash table of classes for any available room and proceeds to move them to that room. Then is the greedy, that we check for courses that have been dictated in a specific classroom of one specific time and take them as part as the solution and removes the unique classroom. And for the sub-restriction, first we have the set classroom, that is the main method for that. And this method is responsible for the sub-restriction that assigns in a recursive way the classroom for every course that goes up through the one we passed for parameter. The soft resolves the sub-restrictions calling the set classroom method. So I'm going to show our code. Here is our code. So first, it reads here all the CSV files and stores them in student, classroom, course. And also we have the key for the main hash map, the solution where there is all the analysis methods, the main where we call and execute the program, and the writer for our output. I'm going to show really quick our CSV files that the problem gave to us and what that we had to work with. As you can see, there are a lot of data. We have, for example, all of this data. And that's it.